On.
It's going well. I'd like
Yeah?
to welcome Saket with us today.
Yeah. Hey, what's up, Saket? How you doing?
Doing good. Thank you for having me.
Anytime,
Yeah.
anytime. Yeah, yeah. So I think the first time we met was at reInvent last year. So we
Yeah.
had a really good chat about data products, and I guess this is still something that's on your mind. So
Yeah.
for people in the audience who don't know who you are, do you want to give a quick intro?
Yeah. No, thank you. Data products is definitely a topic on top of mind for a lot of people. My name is Saket. I'm co-founder and CEO at Nexla. Engineer by background. Most of my engineering career was at NVIDIA. We're just chatting about this before we start the show. Um, and did a first startup building an ad serving company back in 2009. Took that through acquisition and IPO. Advertising was a lot of data, and that was the fun part of advertising technology, to be honest. The rest of it wasn't as much for me, at least. So I decided to start Nextline in 2016, and yeah, the whole idea was how do we make it possible for more people to use data. And it's been a series of innovations going on, and data product has been a key one that we actually started dabbling into around 2017. Just didn't have a right
Interesting.
name for it. Yeah.
Mm. It feels like that's kind of the common thread. Like I think a lot of people had been doing something that I guess we now call data product, but back then I don't know what. So what did you call it back then?
We call it a next set, to be honest. We didn't understand. So what our thinking was that typically people talk about data sets, but data sets are often even like, I have three CSV files and we call it a data set. But the idea was that, when we started working on the company, the idea was that we want to think about the user of data. So many more people are users of data. They're not necessarily or should not necessarily be engineers themselves. So how do they use the data and where do they use it? And the understanding was that the user of the data is in many places. It could be visualization, it could be data science, it could be a person on a spreadsheet, right? Different users of data need the data in the tool of their choice. And how do we present it to them? There's all this complexity of data systems. There's streaming data, there's APIs, and all sorts of legacy enterprise systems. So we thought of like, okay, we need to present some consistent entity to this user so they don't have to worry about what's behind the scene. Okay. So we said, okay, this sort of looks like a data set, but it's not just a data set. Data set could be something very simple. So we started thinking about what are the characteristics of this entity? It was abstracting the underlying data. It had schemas, it had versioning of that. You could put validation rules on it. So the user who gets the data knows that I can, if I have an email ID field, all those fields will actually validate for an email ID, for example, structurally. So there were a lot of things that were going into it, and we could realize that this was becoming a central sort of entity in everything that we thought about. How many next sets does a customer have? How often are they using it? Are they sharing it with other people? So that's the name that we sort of came up with at the time. And it was hard to explain. One of the problems we were solving for people was, hey, you can produce an Excel by connecting to data systems, and you can create derivatives out of it. And these are all logical abstractions. None of this was a materialized view of the data. And then you could consume it. Different people could consume it. So it was effectively creating a data integration. So it was reading the data from one place and was, transforming, delivering the data. So people would ask us, why do you have this? Why not just make a point-to-point connection and just do integration like everybody's doing it? So initially it was something that we had to explain to people, like what's the benefit of it. And then fast forward a few years, it started to make sense to more people. And really, if I walk back, I was thinking that it becomes an entity, a data product becomes an entity that people can sort of collaborate around. And yeah, so there are a lot of ways to think about the data product, but yeah.
This is great. I mean, I think so often the tendency in the past has been to think about, okay, let's build the data model for the organization, or let's build our Hadoop cluster, or let's build our data warehouse. And all of those things can be important, but like the focus on the end user before you focus on those core data abstractions just completely changes the game.
Yeah, I mean, have been in the industry for a while,
Yeah.
and there's always been talk about data democratization, right?
Yeah.
And And at some point, it's like, yeah, data democratization makes a lot of sense. Everybody should just get the data that they need to work with. But over time, I started to feel like democratization was maybe the wrong word we were using. It was what we wanted more was collaboration. Collaboration meaning that, hey, how can people work with data together? Because the democratization concept was a little bit weird. And it's like, what is democratization? Do I give everybody access to the database password or username and stuff, and is that democratization? Everybody just go at it, right? But that is chaotic as well. So I think about this from that perspective. um the, the the evolution of the understanding, at least for me, has been more and more towards the user, how they get the data, how they find it, how they collaborate around it. Because um, I feel like there are two ways an enterprise can scale, right? We can automate things, or we can bring collaboration to our workflows, right? So the user part definitely goes towards that. The technology centers more on automation, I would say.
And I think it's similar to what we saw with open source. There was this idea early on that everyone should just be installing their own software, making their own commits, changing their own code. And at some point, most of us recognize that we probably don't want to be installing the software on our phones, right? We want some expert to take care of that for us. The same thing with data democratization. Like it's great if you have the ability to access those low-level data sets, but most people who need to make business decisions don't have that competence to get in and understand all the details of the data and ensure quality.
It's interesting.
Yeah.
Go on.
What's
Well,
go ahead, Joe.
sorry. I mean, I guess why do you think it took so long, right, to get to this point? Because in retrospect, it's one of these obvious ideas that I think was inobvious at the time. We've talked about data democratization and data breadlines and what else? Self-serve for years and years and years. I mean, this has been sort of the let's say one of the quests of the industry, so to speak. But like to switch it from maybe that to product, I guess in retrospect seems like a fairly obvious jump, at least to me and maybe the people here. But I don't know. What are your thoughts? Like, why did it just take this long for us to finally look at it through this lens? Do you think?
Yeah, I think in many times I feel like in concept we understand how things should be, but enough forces have to come together to sort of make that happen. So I don't think that until really cloud warehouses came in, that the number of people getting access to data so much more easily. Because remember, the DBAs were guarding the database because you just can't go jump into it and create your tables and do stuff like that, right? So I think the opening of the cloud warehouse, where these sort of performance and all of these things were taken care of by the technology itself, did so many people jump into it. And when that many people come into it, that's when I think that all these concepts that we have, like, oh, we should have democratization in theory versus how do we really make that happen in practice, starts to really put the pressure on us, right?
Yeah, I think that makes sense. A lot of sense. I mean, I kind of equate it to like a Potemkin village, if you know what that is, where the um, back in the communist days, they would have these fake villages set up that made it look like there was something going on, right? And I think that what I could tell with vendors is that they would say, "Oh yeah, you can democratize your data access and self-serve," but at the end of the day, it was still guarded, as you say, by kind of the powers that be, right? And so it kind of is what it is. But the world's changing, and so it's changed.
Yeah,
At least,
it's certainly been an evolution, but I do think that we're getting to the point where, as an enterprise, also you realize that data is like everywhere, every function, like
yeah.
every job that you're doing has a data element to it. And then if you look forward, a few years, like how do we scale this? Even right now, it's a scaling challenge. And I think the scaling challenge was focused a lot on the volume of data, which is why Hadoop, came in, and so did all of the other things. But the scaling challenge that is bigger now is not the data volume or processing, it's the people. It's how do so many more people work with data and get to it, and do that in an efficient way. So I think that's where the focus shifts, I would say. And if you look at it from that perspective, it starts to make sense that you do need some sort of an entity that you can get people around. And I think that the data products are, becomes that entity, because we're not talking about data product, as just a collection of data. If I think about data product, and I go back to basics of, what is a product in the first place.
Yep.
In my mind, any product that we use, and I often use this example of shoes as a product because we all use it, but like any product, it is made from some raw materials, right? I mean, there's fabric and leather and all that material that goes in, and it is designed and produced by somebody. And then the consumers can find it, and then they expect certain things out of it, like it's for a particular purpose, like we are running or tennis or basketball or whatever, and they can go use it, right? So that the idea of the product, if we take it from there and say, what does it mean for data product? What are the raw materials? So data is one of the raw materials, but so is the schema, and its change over time. So are the things like, what are the validations that went into sort of this entity? So when I as a consumer can go find this data product, what do I expect from it, right? So the fact that you can find a data product means it has to have descriptions and annotations, and it has to have ratings, validations. But the fact that you can use it, and you can use it wherever you like, coming into a data product and say, I want to do, use it in analytics, or use it in my spreadsheet, or use it in my for my training data, for example. So that means that it now becomes something that has to enable that consumer as well in different ways, right? So I think of the product very much like that. Like if I, as a consumer, come in, it's validated, it's trusted, I can understand it, it's ready for me to use, and I can use it the way I like to use it, right? And yeah, so it sort of feeds back into the need for this entity that people can collaborate around, I would say.
Let me ask this.
Yeah.
What in your previous experience before founding Nextla led you to focus on data products and to found this company? So what in your experience at NVIDIA and in other jobs kind of led to this whole journey?
Well, that's a great question, actually. So at NVIDIA, I used to be in the team that writes the device driver, right? So it's basically right above the, if you know, the typical GPU architecture and software firmware above it, there's a video BIOS, and then above that sits the driver, and then that driver enables OpenGL and DirectX, and then above that come the games, right? So I was writing that driver, and one of the things that was very innovative about NVIDIA was it had created an abstraction of the chip at that layer. So that layer creates an abstraction of the chip. What it does is very interesting in that our drivers could be both backward and forward compatible. So you could buy a new graphics driver, not have to upgrade graphics chip, card, and not have to upgrade your driver and still use it. So the idea of abstraction, where is very powerful in software. The fact that something that sits on top of a complex piece of technology, but gives a common interface to those who come and consume it, is very powerful. So when I started to think about the user of data, and really the thinking when I was starting the company, and in 2015, I spent the whole year researching. I was like, should I go build a company focused on machine learning? Because I could see on the horizon we had been very power users of machine learning in the advertising world for like auction pricing and a lot of interesting things like that. And advertising was huge amount of data. 300 billion records a day is what we were processing in my company.
It's a few.
Yeah. 15 billion ads, 20 bids per on every ad on an average. So it adds up pretty quickly. And the thinking then was that, here, my thinking was like, I wasn't very clear how machine learning space would evolve. And my sense was that it's so unique to every company, like two e-commerce companies may take, may operate that very differently in what they're trying to achieve. So I ended up thinking about what do people need who are going to do these things. So then came the question of data. Everybody I talked to was telling me that data was a challenge. And it was pretty clear that, okay, not only these guys, but everybody else is thinking about data, even a business user. You could be doing recruiting at a company and you're looking at data in how are we getting the resumes and how are we processing them, and a lot of analytics that's now going into that space as well, for example. So the thinking was, here's the user of data. Here's all the complexity of the data systems, streaming and real time and APIs and all that stuff. This user shouldn't have to care about that. So, going back to my roots again, it's like the idea of the abstraction, what is this sort of layer that sits in between? So this side, which is the user, has something simple and consistent to work with, and this thing is taking care of all the complexity behind the scenes. And that's why we said that when we, this side will connect to the data systems, will connect to APIs and documents and, warehouses and everything, but it will present to this user something that is consistent. So for this user, if they are at, their basic know-how should be at a level of being using Excel, let's say, so they can see the data in a more or less tabular format, can be nested, but we can try to present it nicely, and then they can apply functions on it, right? So when we thought about it that perspective, this is what led to the abstraction. And to present a common interface, I needed to create a common entity, an entity that looks the same and behaves the same regardless of where things come from. And that whole sort of the abstraction experience and just focusing on the user sort of naturally led to, let's create this entity. As I said, we didn't know what to call it, so we called it a next set because we thought it was certainly a super set of capabilities over a data set. But one of the things we also did was we created it as a logical abstraction. We didn't say that we're going to take any system we connect, we're going to copy the data into a nice, structure and then make it possible, because it seemed impossible to solve the problem that way. You can't just be copying data from all these places to give your user a view. So we said we're going to create a logical abstraction. It will not materialize the data until somebody uses it. So when you come in and you say, I found this next set or this Air product, and I want to use it in a spreadsheet, it will materialize the data into a spreadsheet. But if you came and said, I need an API to the data, it will give you an API. So this concept of delayed materialization is, again, a common sort of concept in software development, which is like you delay those decisions, but then at the time of the decision, you can then decide what should run behind the scenes to make it happen. So are you now going back to some documents and reading that and delivering the data into a warehouse, or are you connecting to a stream and then giving in, this out and delivering into a spreadsheet? That decision you can take delayed, but it had powerful consequences, which I'm, happy to dive into in terms of many other things that come out of that.
Now, this is fascinating. I mean, were you so rewinding just a bit? I want to kind of explore this NVIDIA topic a bit more, if you don't mind. Were you involved in writing drivers, in interfacing with like the CUDA team?
Yes. So
Okay.
I actually started in NVIDIA in 2002. And what happened was I came in from more of a Linux background and embedded systems background. I worked at a company. I worked writing software for one of the biggest tools provider for Wind River. Wind River, if you remember, the OS called VxWorks, which was going into a lot of devices. So I come into NVIDIA in 2002, and the company is thinking, how do we expand our business? We have been making PCs and laptop sort of chips focused on gaming, but how do we grow? And Jensen's thing was like, where we want to be behind every pixel at the time. That was the message. So I became part of a very small team that went exploring different ideas. So I worked on a digital picture frame at the time, worked on the PlayStation 3 project, did some automotive work. We acquired a small mobile chip company at the time, MediaQ. I was doing the integration because my job was really write the device driver layer that will abstract, so that then once I do my job, all the layers above that should work. OpenGL should work, and you can do all the things you want to do. So a part of the this was the embedded software team. Part of the embedded software team is, then started involving with CUDA as well, which was basically thinking that it's so hard to program the GPU because just thinking about parallel processing and compute is hard. So the idea of the CUDA team was like, how can we create certain sort of layers? So again, same concept, layers that will help programmers write stuff and not have to really worry about, or at least make it easier for them. I mean, from a linear sort of programming model, right? So that sort of all of this thing happened at the same time. I was there between 2002 to 2008. So a lot of this stuff got seeded at the time. For example, we tried digital TV, and we're like, very hard to make that ecosystem work for us. So we kind of put so many ideas that didn't happen. Some that happened, some that ended up being somewhat small. For example, we did technology for these arcade machines in Japan called pachinko machines. So we did some of that, mild success. And then things like automotive were basically like, 8 years of investment before they became a big success, or, CUDA, for example. So, I do remember, my manager, went on to sell these rack units that we would sell, high performance compute, and we'd say, look, we can do 10 teraflops in one rack unit and compare that to 50 gigaflops that you can do with a regular CPU. The challenge was, in 2008, not a lot of people were looking for that level of compute. So we would be basically going into either university research stuff, or oil drilling was, I think, one of the industries that was very compute intensive. So yeah, I think excellent sort of technology that then, of course, found its market fit and continued focus on innovation, which is, I think, what is happening in the data ecosystem right now as well. Is that there's a lot of innovation happening, and we got to keep on it, and it takes time before it matures and shows the full value of it, right?
Yeah, so let me give you my perspective. I promise this is relevant in just a second, but on CUDA. So back then, I was a graduate student. I was a graduate student in physics, and so this like new innovation of GPUs used for scientific computing, I thought was really cool. But then, to your point, it turned out that the ultimate application of CUDA would be machine learning. No one back then, as far as I know, no one I knew was thinking about machine learning with GPUs. But the fact that abstraction was developed allowed NVIDIA to be a huge player. Later in like the LLM space, they're still very dominant in machine learning, deep learning training, because they developed this abstraction technology back then. And I think the analogy with what you guys are doing is that if you build these abstractions, then people will find really interesting ways to use data, maybe ways that you weren't even expecting.
Yeah, actually, funnily, I was road biking with a friend of mine who has been a long-term NVIDIA, VP of engineering over there. And we were talking about what's happening right now, because last week the stock shot up a lot, and they had a lot of announcements at Computex, and we're discussing how a lot of things that we're trying to do in the LLM world in terms of vector and a lot of math that goes in terms of matrix computation is something that's so native to the GPU, because that when you are rendering scenes and and doing those calculations. So we're talking about that and thinking back at the companies we competed with and what was differentiating, and he was like, it's CUDA. It's the software layer on top of the hardware that really became the differentiator. I think you're right. I mean, part of it is that sometimes technology sort of finds that fit. These abstractions, I would say, and one of the things I would love to share more about is how I'm feeling like it is changing the way we are even looking at data management.
Let's go into that.
Yeah, so the whole idea of data management has been that overall there are few things that we have always done. We have done integration of data, we have done monitoring of data, we have done quality, we have done preparation, transformation, we have done discovery. So these things, we're not talking about like they just thought about like a few years ago. We've been doing this since the 90s or even before that, right? I mean, back in the early days of the database, trying to move data from mainframes, that's how a lot of this started. Of course, we have become better at it. It's become easier and all those things. So when I think about, these are the things you've wanted to do on data, and each of them have been silos of, tools and technologies. And there was a lot of black boxes, by the way, because of the way the industry has grown. In many ways, the data product, I feel like, can become the entity that sort of stitches all of this together. And I'll share some ideas on how I think about that, right? So how do we create a data product? We connect to source systems. That's where the actual data is. We try to understand that, and this is kind of what we talk about now as a metadata intelligence, or using, metadata, when does data come? What's the schema? How does it change over time? There's a lot of things you can learn by observing the data. And so creating the data product really goes to the source system and to create that entity. When we take a data product and when we apply some logic to it and say, okay, the data product has, say, a transaction, it has an order ID, a credit card number, an amount, and stuff like that. And we want to derive a new data product which masks the credit card number, or which takes the order ID and finds items in it. So we're applying some logic to it. We're applying some filters to that. We are applying some transformations and so on, right? Validation rules, like does this order ID match this pattern? So when we create the data product by connecting to the system, we transform the data product into more data products. These are derivative data products. And then we consume the data products. And if you think about that, that to me feels almost like we have done extract, transform, and load, but just that we have done this in the paradigm of data models rather than calling it an ETL integration, right? Now, data products, if I can go and find them, what are the data products that are out there, who's using them, how are they rated, and stuff like that, we start thinking about data discovery. For example, if you have validation rules on the data product, they can add up into becoming a data contract. If data products are entities where one of the things that we had done was, it's a logical entity for us, and I'll talk about why the logical entity becomes so important actually. If you apply sort of rules on it, then you can detect the errors and they can be associated with the data product. Like this data product had X number of errors. So error management can become sort of something that becomes part of thinking of the data product. So the data products start to become the connecting glue around it. You can create a marketplace of data products. You can have an exchange of data products. In fact, if you extend this further, this data products can also be, because of being a logical entity, can also be cross cloud. And the reason I think is very important, when I talk about the data product, the concept of the logical is, when we were thinking about the data user, we felt that, okay, we don't know who the data user will be and where they would want to use the data. So if we pre-materialize the data, we said we're going to put every data product will be associated in a table or in some Parquet file or something, then we have predetermined what is the delivery of the data. What, for example, will it be JSON or will it be CSV? Will it be available real time or not? So in order to make it possible that the user of the data can use it wherever they want to, and that decision can be made later, it was beneficial to have the data product as a logical entity, because now this entity is gonna, at the very end, will decide the format and the delivery. But became even more interesting when we started to think about cross cloud, because we run our infrastructure across clouds. And if your data product is technically, the data behind it is really sitting in say, AWS, let's say, right? But you are in a Google Cloud environment, that's where the application is running. And if you refer to the data product and you materialize the data product at that time, it becomes possible for the data product to give you an API or materialize the data, let's say, into BigQuery. And it becomes an interesting way to also think about multi-cloud data. Because that, I think, is one of the bigger challenges that we'll see as an industry going forward is, yes, there are costs to sort of moving things around the cloud, but ultimately when an application executes, where you run that code, you need the data right there. And you think about just, in a compute model, right? You're running the code in a CPU and that data is somewhere in memory right there and it's using that data. So the fact that compute becomes more fluid, and we are already seeing that people are gravitating to Azure because they want to work with OpenAI, for example, right? Or Google for certain reasons, or AWS. Then the concept of logical data product becomes a very powerful counter to the concept of a compute container, right? So not only is it a consistent entity, it's also logical. It's abstraction, and it has that flexibility to support your compute model as well. So that's at least my thinking, that data products can become a central entity, and how we think about integrating the data, how we think about discovering it, how we think about monitoring, preparing, all of those can be thought about as actions on a data product.
It's interesting. So how closely or not does your vision of a data product align with, say, the vision of a data product that maybe data mesh purports?
Very much. I mean, the concept of the data product, as we have learned within the sort of data mesh conversations, does talk about a polyglot entity. And a polyglot entity should be able to deliver the data in different formats and systems. So when you think about a logical data product, that is the most efficient way to do it. The inefficient way to do that would be materialize it everywhere, right?
Right.
The fact that but I think it goes a little bit beyond, because I really like the concept of virtualization that existed back on the database, but virtualization was tightly, I think, coupled with the concept of database in many ways, right? It's the views and all the stuff, right? But if we extend that to like, hey, we could do something similar to a stream or set of files or to APIs, then it becomes sort of very powerful, sort of, a unified entity across the data. And that goes back to the abstraction sort of, concept, how we think about the user, and the user doesn't really care where the data is and what's the format and what's the OAuth token to go validate against that API and pull a record, right? So so that becomes, I would say, something that goes and touches on that aspect as well. What I like about the concept of this data product is that when you get the data product, you get the data effectively. So it has this construct of access control, which means that you can decide who has access control to which data product. It's still a logical entity, but it's sort of a gate in a way. So when you come through that gate and you say, I have access to this data product, and the data product understands where the data was, what series of operations need to be done on it for it to be ready into what this data product is promising you, the validations, the transformations, the enrichments. It sort of becomes a mechanism by which it enables that sort of collaboration. I create a data product, and I gave access to you, and you took that and you made a few modifications to it. You ended up with a new data product. Again, it's a logical entity. We're not loading the system with more copies of data, which a lot of enterprises worry about. And then you go ahead and use that, and then your modified data end product becomes accessible to somebody else who can then take your work and go forward. So this collaboration that becomes possible, and I feel like, again, if you think about the lines between democratization as a goal to how collaboration can, I feel like, be a more effective way of democratization, and the story behind the data mesh. Why did we need the data mesh? We needed the data mesh because everything was centralized, and centralized is not collaborative. And what is collaborative is, it's easier for people to be that producer, consumer, find the things they need to, and get along with their job, not be stuck behind some ticket or a queue or an iterative back and forth process. So I think many of these goals do connect together very nicely.
Well, let me ask a question. I was actually having a conversation with Chris Tabb yesterday. With Leading Edge. But it's exactly along the lines of what we're talking about today. So what we started talking about is what's the difference between a data product and then a usage of data with a product mindset within another product. So let me explain the difference. I would assume data product would be like, internally, I have a team that needs data. I build a data product for them. Whereas data inside a product means maybe you have a SaaS platform and my users need some kind of a dashboard or some kind of analytics for their own data in that SaaS platform. So how would you relate the data product concept to building better products with data inside of them?
I think they're very related in the sense that when I think about the data product, it's not prescriptive about how it gets used. Ideally, the data product is there and different users can come and find it and use it in ways they want to use it. And a SaaS application could be one of those users. A SaaS application could come in and say that I want this data product as an API, because when I make a call to this API, I want the data back to me. I think what it does is that this construct of an entity that you can go interface with and write an application to that, versus saying that I'm writing a SaaS application, and for some data, I'm going to integrate with this API, and for some other data, I'm going to have a file loading mechanism, and for some other data, I have to plug into some stream. So the fact that you can, as an application developer, say that here is a common thing that I can work with, just as we were talking about abstraction earlier, as OpenGL is going to go and use the chip. It doesn't have to worry about what's behind it. So I think that will simplify how we write the layers above that. And that's how software works typically, right? Every layer creates an abstraction or a common interface, and the layer above that becomes more scalable, easier to build, because now you're not dealing with all those variations. So I think that those interconnect. But building a product as a software product is certainly different from a data product. But yes, this data product becomes used inside the software product, if you will.
Yeah, I'm kind of reminded of actually a real product, a physical product, like Coca-Cola, for example, right? Bottling plants take syrup, turn into Coke, Coke is then put into various ways that you can interface with it, I guess, right? You can buy cans, bottles, you can go to a fountain and get it. At the end of the day, it's still the same thing, right? So there's definitely some analogies there. Obviously, there's a giant Coca-Cola organization that centralizes everything as well, but but the whole point is consumption, right? You have various ways to consume it. It's not like I only want you to drink out of glass bottles, so here you go, right? And I think that up to now, though, we've lived in a very much a glass bottle world with data, where it's like if you want to interface with it, you can access this data through, say, this report or maybe this API, but it hasn't been polyglot as much as I think that what you're alluding to is the possibility where we could get to, right? So, but
Yeah, I think getting to that becomes essential for the layer above that, and innovation always happens. The next wave of innovation is always based on the foundations that were built before, right?
yep,
So cloud became the foundation for the cloud warehouses, and the cloud warehouses, and their existence sort of becomes foundation to the layers above them. And I feel like a logical data product, which can give you a common interface to different type of data systems, can be that sort of layer on top of which when you can now focus on the application building side
yep.
of it. And it sort of creates that velocity of innovation. What Matt, you were asking about earlier, like what happens with this, we don't know. But if we do feel like the fact that infrastructure became something that we could say, I don't have to think about it, I just go and use it. And then when data is sort of like that in certain pockets, you have that sort of thing. But what if it becomes this common across any type of data and batch and streaming and real time and warehouses and APIs and JSON and XMLs and whatever, and you have that common interface on that, then it sort of creates a layer where that next layer above it, which is again getting closer to the user of the application, becomes that much more faster to create, easier to create. And that innovation usually comes from that when you open up that ecosystem, correct? I mean, right now I look at so many SaaS products that we use, and if you think about it, one of the biggest buying criteria then becomes what tools you integrate with. Can my payroll system connect with my workspace tool and people management tool, and can my chat application then connect with my Jira tickets? All of that stuff is true, but each company is having to build that, and each of those are point solutions in many ways. But if you create that abstraction layer, then it becomes something that you can really get out of the box for many of these.
Right, or you have to go through like a centralized toll booth, right? There's some companies that obviously provide integrations between various services, but that's expensive.
It gets very expensive. Yeah.
Right, and it's still limited, right? So, what are you saying, Matt?
It's still limited. It only focuses on, I would say, the top 100 most popular tools, maybe 200. But when you go in enterprise and you look at, and I've seen legacy telephony systems are existing, and there are interfaces to get data, out of those, for example, or stuff like that. So enterprise is full of that. And remember, every time a developer writes an application that has an API to it, and you call that API and you get some information back, that is data. And that is data logged behind that custom API that nobody is ever going to build a connector for. Okay, so we really have to sort of think about how some of these things eventually scale, beyond. And many of the implementations today are getting stretched to the limits. Like how many can you really manage? Versus fast forward a few years, and there's only going to be more of these things, right?
Oh yeah.
Yeah, it's funny. I mean, a few years back, APIs were talked about like this panacea, where if we just all have APIs, everything will interoperate. It will be completely magical. And
you've written APIs, right? I have.
Exactly. API connectors. It's very complicated. There's a huge maintenance burden. They break over time. Like almost always, something will go wrong eventually with your connector. Yeah.
Mm-hmm.
Yeah. I mean, I'm always a skeptic of that. I mean, nowadays there's a lot of conversation about this whole thing about zero ETL. There'll be no ETL.
Mm-hmm.
And I'm like, okay, how does it get implemented under the hood? Yes, a cloud vendor is saying that between my two databases, doesn't need to be ETL, be zero ETL, but they basically wrote that ETL effectively, for you, and gave it to you in a box. So
they wrote the E part of the ETL too. It's not like the transform in the E and the L part. You still got to transform
E and
it,
L
right?
part,
So,
yeah. So the T you have to bring, but when we look at it, and when we say, oh yeah, all the data for this SaaS service will be available, out of box for everybody in this, we understand that somebody has to do the job. Somebody has to do the job of saying, from this application and this service, this data will be brought in and available in your warehouse, and only your data will be there or accessible to you and all that stuff. Clearly, somebody has to build a system behind the scenes for that. And I just think about how much time it has taken for companies to really support and build their APIs, which is effectively the same thing. My application has data, and I'm going to make it available to you via a common interface called the API. You can call that and you can get the data. But instead of now giving you the API, maybe in addition to the API, I'm also going to put that data in a table so you can go look at it. But I look at large companies and how big an API team and how much coding they do to support those APIs. I just don't know how magically the ETL will not be something as equivalent to that. So whenever we promise zero ETL, somebody's going to go do the work. And who is going to do that work across, again, many systems and stuff? So we tend to often oversimplify and say, yeah, this just like APIs will solve everything, to now zero ETL will make data available everywhere. But really, how is it going to work, and will it really be as easy or straightforward as you say, right? So and I've been questioning that. I don't know if you guys have been coming across the question of zero ETL.
I have seen it, and honestly, I'm going to be giving a talk in like a week and a half about streaming data. And one of the things I'm going to talk about is complexity budgets, and how often, especially in startups, we don't really plan for complexity budgets. And the problem with APIs and all of these systems is that often there is a complexity budget that you have to associate with that. And so if you can find ways to reduce that barrier, anything you can do to do that means that you can allocate that budget of human energy, of thought, somewhere else and do more interesting things. And that's where abstractions really come in, because we don't have to think about those low-level things. It allows us to think about higher-level things.
Right, like data pipelines,
like data
and
pipelines,
stuff. Right,
and
yeah. I mean, what it does is it kneecaps a lot of the data pipeline vendors to some extent, right? But that assumes that the zero ETL is able to make that translation between source and destination, right? And so far, the sources that I've seen, in some of the big clouds, or like the relational database that's on the other side, right? But it's not like there's every single connector known to humanity is in there, and it just magically makes data flow in. Like, that's not how that works, right? So I think it's good marketing spin. I do give them a round of applause for coming up with something that seems magically awesome. I mean, maybe there'll be negative numbers attached to with ETL, -5 ETL. So it's like the 7-minute abs, and something about Mary, that one scene where you can just keep going down the to 6-minute abs and so forth. I don't know. People want simplicity, right? But but the whole problem with that is, and the reason I make these kind of snarky comments is, as you point out, Saket, there's a lot of work that goes behind this, and I don't think that just magically disappears anytime soon. And in fact, if you're not paying attention, it actually makes it worse in some ways. So, because now you're under the assumption that your source data is awesome, it's great to go. I just need to zero ETL it into my destination, and we're off to the races. It's anything but that. I always found that the source data is still the crux of everything that we're challenged with. I'd say most things.
Yeah.
So
yeah. I mean, some of that sounds to me like a little bit like the no software campaign that happened.
Yeah.
Which we're like, it's still software, you just don't have to install it. So I think it's still ETL.
It's the interface,
you just have to go set it up yourself, and somebody set it up for you. So it's kind of, take that with a grain of salt. But I do agree in general that there are some very, very, very common cases of data from, say, the top 5 or 10 systems into a common system is there. And I think it makes sense that those get solved.
Yeah.
But the spectrum of challenges, I feel like every new application or SaaS application or homegrown application comes in, it creates the need for connecting to it and making that data accessible. So I think that's, as an industry, we've got to figure out how to support those. We've done well with the top 10, top 100, top 200 systems, right? So that's where the frontier, I think, ends up being in some of those challenges. And the interesting thing is that the model has to change. If the model is that I'm going to write custom code for, say, pipeline for system A to system B,
Mm-hmm.
then I can only support so much. So unless the
Right.
model changes, which is where I think again the logical data product becomes, and I'm happy to double click on that as to why that becomes
Yeah.
a way to make that possible actually.
Yeah, let's talk about that actually. And there's a related question here from Robbie. He asks, I thought the data product API is still local to the domain. What is this common layer we're talking about? And I think that's somewhat associated with where you wanted to take this. So
Um, the data product can, what I meant by the data product, the API from the data product is that the data product itself can expose an API endpoint, which can become a way to access the data behind the data product. So I don't know if this question actually means whether there's an API mechanism to go list and find and understand, query a data product. That may still be local to the domain. There has to be an access control mechanism which allows people across a domain to do that. And my general understanding is that at least the way I have built the technology at our end is that anytime we connect to a data system, anytime we find a schema, we end up generating or detecting a data product. Only some of those will become used broadly and widely, and they become what are kind of put out by the domain, typically in the construct of a private marketplace of data products, where you can say, hey, here are the data products that I'm going to put out from my domain because I'm going to stand behind it. And, the validations have been created, it has been documented properly, and, stuff like that. So the ownership of the responsibility of the producer becomes an important role in there. It's not going to be for every single abstracted entity that you keep detecting necessarily. Yeah. But yeah, to double click on what I was alluding to earlier was that one of the things that happens is, at least the way I look at it, is that can we connect to a data system given the authentication and look through the information, parse through that, and use it to generate a logical data product automatically. And if we can do that, then it makes that sort of going beyond the common systems easier, because the ability to probe an API and the data behind it and understand that and present it as a logical product means that we have made it possible for that complex system to expose the data to a common user in a common interface. And a lot of the integration work is really about that. How do we connect to a system and pull the data and bring it to a place where somebody else can use it? But if and that's how at least I've approached the problem, is that can actually increase the number of systems you can support. So then you can say that, I'm capable of connecting to any type of API, for example. So I can go scan through that. I'm able to connect to any type of stream. So one of the problems that that abstraction solves, at least in the integration land, is you have source systems and you abstract that into a set of data products. And then there's an abstraction to the consumption, which is the polyglot output. So instead of doing this m times n sort of source system, destination system sort of pairs, you end up abstracting just one set of entities into a common thing, and that common thing into that. So you have basically converted an m times n problem into an m plus n problem instead. And that is where I think the fundamental shift can happen in terms of how to support systems that are not the most common ones that you can spend the energy to create something custom or deliberate, right?
Interesting. Matt, you look like you want to say something. I think you're muted though.
Sorry, I'm still muted. Yeah. Let me ask you this. So what comes next? So we're here right now, we're working on this data product mindset. What do you see on the horizon, say, over the next 5 years? What big changes can we expect in the data space? So I think we've just come through this era. We had the big data era. We had the modern data stack era. What can we look forward to, and how is that going to interact with data products?
Yeah, I think when I think about the big sort of shifts that or what will power the big shifts, I just think in two big buckets. One is the automation side of things, which is what are the things that can get automated? Can I like, for example, we just talked about automatically generating a basic data product from scanning to the systems, right? I have seen examples where we have seen like automatically scaling your pipelines, looking at the underlying metadata to say where is the bottleneck here? Is it in ingesting? Is it in transforming? Is it in writing? And can we automatically create more streams and dynamically allocate more containers to the respective service and do that and stuff? So there are many aspects of automation. I think so. Automation is one big bucket. And the other part is the collaboration, because ultimately, when I think about many people working with a lot of data from all type of places, both of these come into play. So the automation collaboration both sort of come into picture. So what are the big things that can happen? I feel like one at least driver for big things can be opening up that underlying metadata or know-how in the system. So for example, until now, many systems have been black boxes, right? So your ability to stitch together solutions is much more complicated or difficult because you just don't know how to do that. One of the aspects I feel like is opening up that metadata. So one of the things that I've been doing is like everything should be accessible from our system through APIs or consumable as a stream. So I think that can be one of the big drivers. The consequence wise, I think that the wave is shifting into how we build applications, because the warehouse technology, I would say, is settled, and what comes after that is the next wave. So big things that I would say can happen coming forward is if we can get to one, multi-cloud data, for example, is a big thing. I'm actually involved with the UC Berkeley Skylab. The Skylab's concept is to create a sky above the clouds, and we've been, founding supporters of that initiative. So I think that can be a big thing in how we sort of make things happen across clouds. So that can be a one big driver. I don't know exactly how it will impact things, but I think it will increase the pace of innovation because clearly each cloud vendor has its strengths. A few years ago, they just used like it's all looked like they're the same, but I can at least see now that they're gravitating towards their ecosystems or strengths. So I think that can be one big thing that will happen. It's still in its infancy as far as the concept, but it makes sense to me at least where a data product is a first class logical entity just like a container is, and I think that changes when compute and data are both abstractable into these systematic entities. That can change a lot of things. So I think that is one big thing that will happen. I think collaboration will continue to increase. I'm really hoping to see that we can actually get to a point in time where this sort of long held goal of democratization starts to feel like any person who needs to go work with data can go do that relatively quickly. Find the data, get to it, and use that. It's still a big challenge, I think, but I think that opens up the applications of data to a much broader way. Um, so that's the other part. And then from the automation perspective, I think there's a lot to come. There's so many things that are still manual. I'm very excited about generally the generative AI space because of ways in which it can generate at least reliable snippets of code. I'm not yet sold on to like building full software on it, but can we create simple data transformations? Until now, transforming data, unless it is something basic, requires a little bit of technical skill. SQL can be fairly technical skill eventually as well, as does like Python or JavaScript. But can we do some of those generative is again bringing it back to the users and making it more powerful. So I think of this as the classic disruptive innovation, when there's a piece of technology that can only be used by it's very high end, and then you sort of open it up and anybody has access to it, and the consequences are in many ways unimaginable, just like we have seen with the world of phones, right? I mean, wireless phones in the 80s 90s to cell phones in everybody's hand, and it's like nobody could predict what would come out of that in terms of application.
Well, and maybe announced this week a new headset that'll just magically transform.
Yeah,
we'll start running into walls now instead, so that'll be a lot of fun.
That's right. That's right. Yeah.
I mean, what are you guys seeing? I mean, you have so many conversations going on with folks, right?
Yeah.
In terms of the frontier end.
I think the thing I'm thinking about and talking about with people with large language models and automated code, for example, is more along the lines of how do you preserve meaning right, of the concepts that you're trying to translate. So say with data modeling, for example, right? Data modeling does exist. It's not just physical data modeling and the transforms, it's also higher level abstractions, right? Like what is a business concept we're talking about? Who cares about this? Why does it matter? What are the rules and processes? Like that's one thing I've been thinking a lot about and talking to people about. Like how do you maintain this and how do you actually make this better? I feel like that's the divide that I've seen with the high level concepts versus how it's implemented in software and maybe in data warehousing. That's a giant gap right now.
Mm-hmm.
Maybe large language models actually fix this in some ways, right? Maybe it makes it a lot easier because now it's so, because what happens is right now that because there's such a disjoint interface between the concept and how it's translated down into the data, these things they diverge. That's what happens. And so
Yeah.
maybe this provides a unified way of looking at data and preserving meaning. So that's one thing I've been talking to a lot of people about for obvious reasons. I don't know, Matt, what are you seeing out there? What are you talking about?
Yeah, a couple of things very related to what you guys are talking about. I think one of the really fascinating things about large language models for me is that the more I look at the applications and the more I play around with them, I realize that these are, so a database you can think of as a tool that maybe augments humans, but also just augments machines. You can have software talk to a database, and the software talks to the database, the human never directly interacts with it. Whereas large language models are specifically, I think, a tool that's really good for enhancing human capabilities. So going back to the software discussion, Saket, like I would never just have a large language model write code and then try to deploy it without checking it. Like you need a human in the loop to work with these tools right now. And so to me, that's kind of fascinating because I'm curious what that will lead to in terms of like augmenting human capabilities. And then there's the second ethical question about how maybe LLMs do eventually replace more human labor and what that does to the labor market and everything else. But I think for now, we're not at that point. But I think that is closely related to what you're talking about, Joe, this idea of pretty dramatic enhancement of human capabilities in terms of designing data models, for example. Like you have this intermediate layer that can do a much better job of translating human thoughts into something useful.
Yeah. That's and for the audience out there, I know I've talked about this wonderful book I'm writing. This is exactly why the book is late. Is because everyone started using ChatGPT all of a sudden. And I'm like, huh. And Copilot and everything else, and then it got me thinking. Okay, so what's the next bridge? Because lots of navel gazing and pontificating right now, trying to figure this out. Because this is, as you point out, it's like new interfaces, new ways of interfacing with technology. We're at an inflection point right now, and the thing is, we're creeping up on the inflection point. Nobody knows where this thing goes,
right?
Which is exciting. It's sort of like a roller coaster ride too, in some way. But you didn't see the roller coaster before. You just hopped in the car and now you're on it. So, I have no idea. It's exciting though, right? Like you've been in the game for a long time. You've been in tech. I've been in the game for a long time, and it's like you see these points and you sort of have this sixth sense, like okay, like this time's different. Something's happening here, and this definitely feels like one of those periods.
Yeah.
So Matt's been there too. So
it's certainly a different in many ways. I think there's certain capabilities that we have not seen before, but at the same time, I would also say that, for example, just Matt, what you were talking about code, right? Any software developer you ask, right, the amount of time spent in actually typing the code is not the main sort of point, right? It's like understanding the sort of business need and translating that into a system design, and then how you test it, and many other sort of things, the architecture and all of that stuff takes a lot more time than actually once you know what you're doing. The amount of time it takes to type out the code is actually not that much. I think again, Copilot and stuff, I mean, it's good assistant, I think we are also seeing some of the limitations of these approaches, but at the same time, we don't know how this will evolve in the next few years and how much more tuned and sophisticated can it become. So it's certainly an inflection point. I think what I think from a general perspective is that it can certainly help people who are working with data to to better, I would say, understand what's the connecting the dots between the business and the data
Mhm.
itself, like what
Yeah.
you were talking about, Joe. And when you go talk to people in a company, in a large enterprise, and you say, they'll be like, oh yeah, we have, there's no one single definition of a customer
Yep.
or a gross margin, for example, and these things are hard and sometimes complicated. So helping to stitch those together is going through mounds of information, and if there are mechanisms that simplify that, I think that can be very powerful, right?
Mm-hmm.
Yeah. And I love the phone analogy. I remember there's an app
Yeah.
for that era right after. So at first the iPhone didn't even have an app store. And then once Android and iPhone started to have apps, all these interesting applications came out that no one had ever thought of before. Like, Airbnb, for example, I assume that no one was thinking about that. Someone came up with the idea like, hey, we could do this with the phone and people could rent out their places, or Uber or any of these other apps. And I think we're about to see the same thing with large language models and other generative AI. And a lot of that will integrate with interesting traditional data applications for the enterprise
And data
for
products.
insights. Yeah.
Mm-hmm. Yeah. Really, really cool. Fun chat. Like I said, it's always fun chatting with you. I feel like you're it's like the way you think. You just operate at a different plane, and so when I talk to you, I feel like I come away smarter, and it's awesome. So yeah.
Well, thank you. It's fun having a group conversation on these topics, because I think so many new things come out of that.
Yeah.
Yeah, that's why I'm like still in this place where we still have an office and we go there and 3-4 days a week and sit with people. I feel like there is a certain things to that interaction that sometimes is just very hard on scheduled conversation. So this sort of
Yeah.
conversation where there's not a preset format and we go through discussions, which is actually, to be honest, it's very hard in a company. It's very hard in a company to have like, oh, let's have a sit on the Zoom for an hour. There's no agenda and we just chat about different topics,
It
right?
throws people off, I'm sure. They're
Yeah,
just like,
yeah.
because you're trained to think
But
about the agenda for a meeting, right? So
exactly.
Yeah.
But you go for a coffee with the same person and you sit there, or for dinner, now what? And that's, I feel like a lot of the interesting stuff happens in those unscheduled or unplanned, I would say,
oh, absolutely.
non-agenda discussions. Yeah.
Yeah, they're beautiful. Yeah, I definitely encourage people to do that. My favorite thing was always going on walking meetings with people, and there's no agenda. Go for a walk, get outside, and just you get stimulated. And the things that come out of that, as you're saying, it's impossible to replicate that. So it's really cool. For people who want to learn more about you and what you're up to, how can they do that?
Yeah, I mean, I'm on LinkedIn and reasonably active over there.
Yeah.
So you can find me certainly from this from the show, and then of course come by nextlayer.com. Definitely, we have been thinking about many data challenges and problems in different ways, and love the conversation and discussion. I
Yeah.
think we're all heading in towards more needs and more challenges, and collaboration and discussion is a great way to identify the best solutions.
Absolutely. Yeah, for sure. And then you're going. What events are you going to be at this month?
Yeah, I'm gonna be at the Snowflake Summit
Okay.
coming up. I'll also catch in a bit of the tail end of the Databricks
Nice.
conference. There's more stuff coming, down later in the year as well. So a bunch of I do a lot of these Gartner events as well. We get to meet chief data officers and CIOs. It's called the Evanta event. So we do a lot of those actually.
That's cool.
Yeah, but yeah, typical stat, AWS reInvent and all of that stuff certainly be there. Yeah.
Nice. We'll see you at reInvent.
Yeah,
Awesome.
of
Yeah.
course.
Well, thank you. And Matt, anything going on with you upcoming?
Yeah, on Wednesday there's the Enterprise Data Summit coming up, and I'll be on a panel with Mark Freeman, Chad Sanderson, and Jasmia Henry then. The URL for that is Enterprise Data Conference, so that it's Enterprise Data Summit, but the URL is enterprisedataconference.com. And then on the 13th, I'll be speaking at Apache Beam Summit in New York City. That's at Pier 57. And if you want to get tickets, I think you can get them at beamsummit.org. That will also be broadcast as a stream on the 18th if you're interested in that. So, and if you're interested in any of those events, feel free to reach out and I can connect you.
Awesome.
Oh, if I can add, then I'll just say
yeah,
that at the
sure.
Snowflake Summit, we are doing this happy hour at a place called Flight Club. It's a darts place.
Oh,
And
Flight Club?
looks
Oh,
like
that's really
Max
cool.
Flight.
Nice.
Yeah, Flight. That's a cool name actually.
Yeah.
It's a darts place, and then we're doing this with a few other companies. I think Excel Data, Selectstar, Primavera. So
Cool.
it's open. Come by. We've been sharing the invite link. Love to see people. So definitely look for that Tuesday, June 27th. Yeah,
Awesome.
we're doing that.
Nice.
27. Very cool. That's awesome. Let me see. Next week we got Colin Zima from Omni on the show, so that's going to be a lot of fun.
Oh yeah,
He's fun to talk
he's
to.
awesome.
So, yeah, it's going to be good. I don't have any events coming up until Vancouver, which is I'll be there the 21st to the 23rd, and then I'll be in San Francisco the 27th to the 29th or something like that for some various things around the Databricks Summit, and then I might be at Snowflake Summit Monday. I don't know yet for Ethan's happy hour, but anyway, fun times. I am looking at my calendar and I have like 15,000 podcasts I'm doing, so that is really fun. So stay tuned for that. Actually, got one from John Coute dropping out tomorrow, so he's from Stream, so that's gonna be dope. But yeah, just kind of laying low, so just rare these days, but. Well, cool. Saket, it's wonderful talking to you as always. And so I hope we get back on again, or you can be on my other podcast. We can chat even further. So,
yeah, thank you for having me. It's been a pleasure.
Anytime,
Thank you,
man.
man.
Anytime. All right, take care. Thanks, audience. See ya. Bye bye.